Right, here's the data for the force on a current carrying conductor. So, going to run it through as details, so we've got everything that you need. However, you choose which methods you're going to do. Reproduce it, so do a graph with two data lines on, but you choose what data, what independent variable you're going to have. Okay, so simple thing, we've got an ammeter here, got the balance here, and I've got a power pack to adjust my current with. In here, as part of the circuit, as part of risk assessment, because I'm going to be using large currents, I don't want damage to the power pack, so I have a 2.5 ohm resistor that I'm going through as well, so that should act as a bit of a load, take some energy out of the circuit. Okay, so that's basically it, nice and simple. To make sure I've got a fair test, what I've got is true readings. I need to make everything the same and make everything right. So I've weighted down the base of this, so it doesn't really matter too much if I lift up or push down onto the balance, as long as I get a change. However, this has to make sure it doesn't move. So what we've got down here is we've got a straight wire. This is the basic principle, just to double check you can see what's going on. This is a narrow one, so I'll do this as well. But the length that actually fits inside the magnetic field is the bit that matters. This one and this part, the two vertical bits, will have a force, but they'll both cancel out because they'll push against each other. So it's just the horizontal length. So first things first, let me just adjust down. We will put on the magnet. Okay, so we're going to make sure this is in the middle of the balance, because otherwise the readings won't be correct. We've got a mass here, but I'm not going to adjust it yet. What I'm going to do is adjust this. So first thing is, I'm going to make sure this is horizontal. Okay. I also want to make sure that it lines up parallel to the magnet, so the wire is 90 degrees to the field. And lastly, I need to raise that up a bit because it's not quite in the center. Now, to start off with, I'll just get that square. Start off with, the wire sticks out both ends of the magnetic field, so they overlap by 5.0 centimeters. Okay, 5.0 centimeters. So everything's all set. Turn the current off. We have a zero error. Okay, but that doesn't matter. But we will need to make sure that that is subtracted from each reading. So everything's ready. I'm now going to tare my meter, T-A-R-E, set it to 0. So I will move up fairly slowly, freeze the video as the force changes. Okay, so freeze when you want. It's going to be a little zigzaggy on your graph. It doesn't matter too much, but I'm going to go up to 5 amps. Okay, so I'm slowly going up. 2.5 amps so far. Freeze it to get your readings. Okay, 10 readings would be good. Okay, so just over 5 amps there, just turn it down a little. Okay, so that's the first bit. What I'm going to do is change things around a little. So, second thing, I'm just going to go right back, is we could change the magnetic field. The only problem is we don't know the strength of this, so I'd have two unknowns. So I'm not going to do that, but if I wanted to, I could simply put 2 more magnets inside to make the gap between them smaller, but also 2 more extra magnets, so it would make it a lot stronger. What I am going to do instead is I'm going to change to this. So this width is 2.0 centimeters. So it's the nearest millimeter, 5.0, 2.0. So 2.0 length of wire, 2.0 centimeters length of wire. Still got roughly the same residual, so you will need to record that 0 error and subtract that, because all the numbers will be 0.03 too big. It's just about 3 staying. Now, this got quite hot in that short time of the last video, so I'm going to race through a little bit. But again, it's about the idea of risk assessment. So you can draw a risk assessment on this. It's important to put one, especially as the currents are so large. Right, re-tear. So we've got our 0. And I'll stop talking because it will adjust the reading if I breathe on it too much. There we go. Okay, back to 0, and then we'll start. Obviously the numbers are smaller because we've got a smaller length. So this line will be lower on your graph. Okay, that's your largest reading at 5 amps. So I'll turn that off to let that cool. So you'll have 2 sets of results, 2 sets of current flowing through 2 different lengths, but both of them should give you the same value of B. One of them will probably be more accurate than other, your final value, but you're actually unknown. So for the 2 lengths, your 5 centimeters of overlap, okay, so that's the length of those, 2.0 centimeters, and let's get a graph of those. Okay, so in your plan, please put everything else. It's all about the plan. What are you changing? What are you measuring? What are you keeping the same? And that's about how you set it up. So where the magnets are, about the angles, whereabouts is pushing on the pan, resetting to 0, etc. Risk assessment and everything else. Okay, the data should give you a lovely straight graph.